Hi everyone, I'm Rakesh and welcome to another video of Theata Essence. Today I will deep dive into what is ChatGPT, how it internally works, what are the different layers involved in GPT architecture, how data is represented and stored internally, how memory comes into picture, and how we can compare GPT with large language models. So let's get started with what is ChatGPT first. ChatGPT is a highly trained AI language model created by openai, and it is built on top of generative pre-trained transformer architecture, also known as GPT architecture. We can consider ChatGPT as a highly trained linguistic engine that has read much of the internet content and have the ability to predict next word in the sentence with the fineness of understanding in context, tone, and meaning. If we imagine our brain as the library, then we can consider ChatGPT as the super librarian who has read all the books in the library and synthesized the content. Further, it has the ability to generate coherent and insightful paragraphs on demand. The human-like nature of ChatGPT is not the magic, but it's the mastery of identifying and recognizing patterns. It has the fineness of understanding, recognizing, and replicating linguistic structures, emotional tones, and natural reasoning that it has seen millions of times during its training. However, ChatGPT do not think or believe anything. It's an illusion of understanding built on probability and data density, just like the mirror reflecting the vast amount of collective human knowledge. To further add, ChatGPT does not know the answer, but it knows how to generate the answer and what the answer should look like. With this, we can now define what is ChatGPT. And so next, let's understand how it internally works. On the high level, ChatGPT has four main core aspects. The first one is tokenization, the second one is embeddings, the third is transformer architecture, and the fourth is decoding. So now let's deep dive into each of these core aspects. So the first one is tokenization. Under tokenization, ChatGPT will convert the user input text into tokens, which are the numeric representation of chunk of text like words, part of words, or symbols. For example, if the input sentence is ChatGPT is cool, then first it divides into words, and then each of these words is converted to tokens, and ChatGPT generates the numeric tokens through a massive dictionary learned during training. The second is embeddings. Under this, each token is converted into a high-dimensional vector space. We can think of this as placing every word in a multi-dimensional map where words with similar meanings are placed together or closer to each other. For example, similar words like king and queen are placed together, whereas similar words like apple and banana are placed together. Now, let's understand how a high-dimensional vector space is represented in programming. Here, I have a embedding matrix. Under this, I have a four-dimensional array, and it has 4 rows and 4 columns. The first row represents the first word, the second row represents the second word, and so on. So under this, it has the concept that Chat and GPT is relevant to each other, so they are close together with similar numbers. Likewise, is cool, these are 2 words which are relevant to each other, and so they are represented with numbers which are closer to each other. The third is transformer architecture. We can consider it as the brain of ChatGPT, and it consists of layers which perform mainly 2 operations. The first one is self-attention, and the second is feed-forward network. So on the self-attention, it determines which words in the sentence are relevant to each other. For example, in ChatGPT is cool, the word chat and GPT are relevant to each other and the word ease and cool are relevant to each other. So this way, ChatGPT understands that we are describing ChatGPT as cool, but not just the random list of words. Now, let's understand how self-attention is represented in programming. Here, I have an attention output matrix. It's a 4-dimensional array, and inside we have first 2 rows with similar numbers that represent both word chat and GPT belong together. Likewise, we have the 3rd and 4th row have similar numbers that represent the word ease and cool belongs together. So this way, ChatGPT understands the words are related to each other through self-attention mechanism. The second operation is feed-forward network. After attention figures out the relationship, this layer processes those patterns to further understand deeper context and refine meaning, like adding logic and nuance to what attention has connected. To understand how feed-forward network is represented in programming, I have a sample example here. I have a feed-forward output matrix. It's also a 4-dimensional array or matrix. And here I have a list of numbers that represent certain word, but in this case, the list of numbers have deeper context and refined meaning. To add further, the real ChatGPT models have several hundreds of layers that provide deeper reasoning and consume more computation. To highlight, the transformers do not read every word all at once. Instead, it reads a small portion at a time, like scanning through text with a moving window, also known as context window. We can think of it as reading with a highlighter. You've only focused on few sentences, but you remember what you just read to keep the story flowing. To understand further, we can imagine a person reading a book through a small viewing frame. They slide it line by line. They don't see the whole page, but they remember the key details from earlier lines so that the story makes sense. This way, the transformers stay focused on the most relevant and recent words while still keeping track of what came before, maintaining a smooth and logical responses even in the long conversation. The fourth step is decoding. We can consider this as the process of generating the next word. Under this, once the model understands the context, it predicts the next most likely word or tokens. It repeats this process iteratively until a full response is generated. It is not calling the memory, but it is generating the next word or text token by token. To understand further, we can imagine someone finishing your sentence by statistically guessing what you would say next, but doing it 100 times faster and more accurately than any human. So to understand how ChatGPT internally works, it mainly uses these 4 core aspects or steps. First, tokenization. Second, embedding. Third, transformer architecture. And fourth, decoding. The second topic is memory in ChatGPT. Initially, GPT models were stateless, where every conversation was independent. Now, OpenAI has introduced session memory, which acts like the human short-term memory and long-term memory. The short-term memory in ChatGPT is also known as context window. It is the model's internal working memory, and it can remember and recall certain amount of tokens or words from the current chat session. For example, the GPT Model 3 can remember approximately 4,000 tokens, which is equivalent to 2 to 3 pages of words. Likewise, the ChatGPT version 4 can remember approximately 128,000 tokens, which is roughly 100 pages of words. Under short-term memory, once the limit is reached, the older context is forgotten. The attention mechanism within the lower and middle transformer layers directly consume the session tokens. Each layer reweights the attention dynamically based on the recent input, and these are directly tied to the session context window or session memory. On the long-term memory, the ChatGPT model can remember facts about you across multiple sessions. This will include information like your name, preferences, your chat conversation topics, and conversation history. ChatGPT uses external memory strategy, that is vector database, to store and retrieve information regarding the chat conversation history. The vector database stores the embeddings, that is the semantic fingerprints of the information. When you ask ChatGPT, it will retrieve the most relevant information from vector database using similarity search and feed it to the context for reasoning as context augmentation. This process is often called as RAG, retrieval augmented generation. To compare, we can think of short-term memory as the current browser tab, while the long-term memory as the bookmarks in the browser. The third topic is ChatGPT versus large language model. Under this, we will explore the similarities and differences between ChatGPT and large language models. Large language models literally mean many layers, both conceptually and computationally. It is the core of the model that is trained with vast amount of data. To add further, ChatGPT is the chat-based application with user-friendly interface and safety features built on top of the large language model. We can consider ChatGPT as the applied, refined, and user-friendly version of large language model. To compare further, we can imagine ChatGPT as a fully built car with steering, dashboard, and safety features, while the engine of the car as large language model. Both ChatGPT and large language models are linguistic engines. To add further, we can consider ChatGPT as the generic translator fluent on all topics, while the large language model as specialized translator. For example, we can consider large language model as a specialized medical translator or interpreter which is fluent only in the language of medicine. To highlight, large language models have similar layers like that of ChatGPT. On the high level, it also includes embedding layers, transformer layers, and output layers. The core difference between ChatGPT and large language model is in the transformer layers and how it is implemented. Transformer layers include hundreds of layers and it differs in the implementation based on its objective and its purpose. In 2018, GPT Model 1 was introduced as a proof of concept and it has the ability to perform many natural language processing tasks. In 2019, GPT Model 2 was introduced with better coherence and context awareness. It was trained against 1.5 billion data parameters. In 2020, GPT-3 was introduced and it was trained against massive internet data, that is 175 billion data parameters. In late 2022, GPT Model 3.5 was introduced with optimized reasoning and instruction following. This is when ChatGPT became widely popular and gained millions of customers or users just within a few days. Today, ChatGPT has roughly around 125 million active users per day and around 800 million active users per week. Next, let's look into the top 12 layers in ChatGPT. The first layer is input embedding and it converts input token into dense vector. This is also known as the embeddings layer. The second layer is the positional encoding and it adds information about the position of tokens in the input sequence. The third is the multi-head self-attention layer and it computes attention scores to focus on relevant parts of the input sequence. The fourth layer is the scale.product attention and it computes attention weights focusing the token dependency. The fifth layer is pre and post normalization. It stabilizes training by normalizing activation functions across neurons. The next one is feed-forward network. It applies a two-layer fully connected network to each token. The seventh layer is the residual connection. It adds the input of the feed-forward network to its output for preserving information. The eighth layer is the normalization layer again. It normalizes the combined output from feed-forward network and residual connection. The ninth layer is the stacking of transformer blocks, and it stacks dozens of identical transformer blocks for deeper understanding. Under output layers, we have output projection layer, softmax layer, and token selection layers. Together, these layers helps to generate the next token or words in the sentence based on probabilities. Looking ahead, ChatGPT is evolving and improving as both linguistic and cognitive collaborator, providing dynamic assistance through text, audio, and video. If you like the contents that I presented today, kindly subscribe to Tiara Essence, and thank you for watching. Stay safe.